percentage calculations. Okay, so there's quite a lot of percentage calculations we need to do in maths. One example is where we want to find one number as a percentage of another number. So for example here, I might say to you that if I had 20 out of my 30 students in a class were females, then what percentage of my group are females? Then I put the number that I'm interested in on top. So I'm interested in the females, so I put the 20 females on the top. And then I put the total for my group on the bottom. So in this case, my whole class was 30, so it was 20 out of 30. That, if I do just that on its own, so if I just do the fraction, what that's going to give me is a decimal number. And if you're happy with interpreting that, you can go with that. And if not, timesing it by 100 will turn it into a percentage, which in this case will be 67%. So as a general formula or rule, if you like, what you're going to do is you always put the group or the number in the group that you're interested in on the top of your fraction, and on the bottom of the fraction you put the total. That, as I say, will give you a decimal answer. If you and then you would always just times that by 100 to turn it into a percentage. So if you're happy with just finding the decimal and interpreting that, you can just do that. Otherwise, timesing it by 100 will turn it into the percentage. The next thing we need to do is a percentage change. So when we do a percentage change, we start with one number and then it changes. So for the example I've given you underneath here is if I started with $200 as a cost for something, and then that thing now cost me $215, I might be asked what percentage change did the price sort of undergo. And so if I wanted to do that, my formula up here is I always put the new price or the new number on the top of my fraction. I put my original number or my starting number on the bottom. If I do just that, so you can see here I've circled this equation, that fraction there, that in itself is a multiplier. So if you're happy interpreting multipliers, then you can just sort of just do that and then interpret your multiplier. If you don't like interpreting multipliers, then you're going to subtract 1. Keep all of that in a bracket so you don't get a BIMDAS error, and then times your answer by 100, and that will give you the actual answer as a percentage. So for example here, if I had that $200 thing which now became $215 worth, I would put the new price, so the $215 on the top of my fraction. I'd put the starting price or original price of 200 on the bottom of the fraction. That on its own would be a multiplier, and that would give me a multiplier of 1.05. And hopefully what you'll remember is that every time we have a 1 in a multiplier, timesing something by 1 would keep the same amount. And so the 1 shows me that I've still got my original amount, and then the extra 0.75 tells me that I've increased my price by 0.75. So as long as I've got a number of 1 or more, I know I've gone up. If I had a number that's a multiplier that started with a 0, then I know I've gone down, because if I times anything by a number less than 1, then I know I'm going to reduce that number. So in our case, if I was happy interpreting multipliers, I could see from this that it's going to be a 7.5% change. If I wasn't happy with that, then taking away the 1 would leave me the 0.75, and then timesing it by 100 would convert it into a percentage, which is 7.5% in this case. So that little formula would be a good one to put on your cheat sheet. Percentage change. Easiest way to remember it is new number over old number, and just interpret it as a multiplier, and then that's all you actually need to do, and hopefully you'll be comfortable with those multipliers by now. Okay, let's move on here. Percentage increase. So often they won't say to you outright that what you're trying to find is a percentage increase. They'll use other mathsy sort of words, so make sure you're familiar with all the words that basically mean you're going to increase. So it would be things like a markup. That's cases where you might own a shop, so you'll buy something for the words are leaving me, but you'll basically buy it more cheaply, and then you'll put a markup on that so that you actually make some money out of selling it. And so that would be a markup. Then you've got inflation, which is just those sort of natural price increases. Natural price increases that apply to everyday sort of goods. Then you've got appreciation, which is also price increases, but they apply to capital assets. We also have surcharges. That's generally an extra charge if you use a credit card or those sorts of things, or sometimes it's an extra charge because you're at a place on a public holiday or something like that, but it's an additional charge, a bit like a tax. But it will basically increase the price you're paying by a percentage. Profits means that you've had some kind of percentage increase in the money that you started with. Taxes are of course an additional expense as well, so that would be a percentage increase as well. So look for your buzzwords, and then once you know that you're definitely going up, you're going to apply this formula here. So basically what we're doing here is we're using a multiplier. So this 1 plus whatever my percentage is on 100 is what we call a multiplier. I'll write that underneath so that you remember. So that bit there is what we call a multiplier, and we call it that because we're going to multiply this number by our original number to find our new amount. Now, the percentage over 100 is just converting. We always use percentages in their decimal form, so that will just convert it. So if it was 20%, that 20 over 100 would give me a 0.2. So my multiplier in that case would become a 1.2. And again, I know that as soon as I have a 1, so I'll just write this to the side, if I had a multiplier of 1.2, the 1 tells me I'm keeping my original amount, because 1 times anything will just keep the amount, and then the 0.2 would increase it by that 20%. Okay, so for example, if I wanted to increase $320 by 15%, what I'm going to do is go 1 plus my 15 is my percentage. Oops, sorry, I did not mean to undo that. 15 on top because that's my percentage, divided by 100 turns that into this decimal, the 0.15. So I wind up with a multiplier of 1.15. I'm going to times that by the original number, which was the 320, and that would give me my new price of 368. Now, I've written mentally on the side of here to remind me, to remind you that you will need to be able to do a lot of these calculations mentally. So you need to remember a few of those basic rules for finding. Generally, you're going to make use of finding 1% or finding 10%. So basically, it's logical that if I wanted to find 10% of a number, there's 10 lots of 10% in any whole. So I'm basically dividing my number by 10%. So if I started with this 320, to find 10% of it, I'm dividing by 10. There's 1 0 in 10, so I'm moving my decimal one spot. So 10% would be $32 in this case. Now I want 15%. So to find 5%, obviously if that's 10, if 32 is 10%, then I can halve that. 5% is half of 10%. So if I halved that, which would give me $16, $16 would be my 5%. So altogether, my 15% would be the 32 plus the 16. So that's going to give me $48. That's 15% off, but I wanted to have 15% increase. So I would then be adding that 48 to my original number. So in this case, 320 plus my 48 to make sure I actually get that that final number. So, and I get my 368, which I sort of had already done on the side there. So make sure you remember those mental rules. In the next one, I've got a 3%, so that'll give us a chance to look at the 1% rule. So for 10%, as I say, there's 10 lots of 10% in a whole number, so we move the decimal one spot, we're dividing by 10. For 1%, there's 100 lots of 1% in any whole number, so we're dividing by 100 to find 1%, which means we just move the decimal by 2 places. So let's do this. First, I'll talk you through the whole process. So if I was just following my formula and plugging in, then I'm going to go 1 plus my percentage, which is 3, divided by 100. 3 divided by 100, I'm moving my decimal 2 spots. So if I was doing that, I'm moving my decimal 2 places over here, which gives me the 0.03. I'll just take that off so your notes don't look too weird. So I wind up with that 1.03 is what we call the multiplier, and again, having a 1 tells me that I'm keeping the original amount, and the 0.03 will increase it by that 3%. So if I had my calculator, I'm just going to go 1.03 times my 200, and I'd get an answer of 206. But again, if I had to do it mentally, it's probably going to be quickest just to use that 1% rule. So in this case, if I start with $200, to find 10%, I'd divide by 1 spot, so that would be $20. To find 1%, I'm dividing by 100, so I'm moving that decimal 2 spots. So 10%, 1% is going to be equal to 2. Now I want 3%, so I'm just going to times that 1% by 3. So I want 3 lots of 1%. So if I times that by 3, I'm going to wind up with $6. And so that would be how much I'm going to go up by. Don't forget to add it on because you are increasing. You're not finding 3%, you're increasing by 3%. So in this case, I would have gone 6 plus my original amount of my 200, which would have given me 206. And I haven't kept that very neat and in line there. But you get the gist there. I'm pretty sure you can all add 6. So that's one way. The other method that I'm going to wind up showing you, and I think I've done that on the next one, is basically you could also have used that Arabic method. And I've done a whole video on the Arabic method. These numbers were nice to work with, but if you had numbers like something like 17, where you'd have to find a 10% and then a 5% and then a 1% and add that on twice, then you might be easier just to move straight to the Arabic method and do that. So we'll have an example, I'm sure, in a moment of those, so I'll leave that for the moment. If I had an item that cost $2.14 after a 20% markup, what was the original price? Now, these are the questions that people tend to struggle with a lot more. In these questions, and I might take away all my working at the moment, just so that I can explain. I'll put this in here as a reminder to myself to show you. I'll remove it all for the moment though. And I'm just going to talk you through your thinking process, because mental tends to be people's weak point. So these questions people always go wrong. It's easy when you're trying to find a percentage of a number, but here we're saying, well, we've already applied that percentage increase, and the outcome was that we're now going to pay $2.14. So in this case, what you have to do is talk yourself through that process. If I'd known all the numbers, what would I have done? So for a 20% markup, I would have gone 1 plus, I would have put my percentage 20 over my 100. That would have given me a multiplier here of 1.2 if I did that whole bracket. And I would have times my number, which is the number I don't know, my original number, by that 1.2. And the answer I would have got, the increased number, was the 2.14. So now when I want to find x, if I had to go old school, I would then just rearrange that equation. So the x has stayed where it is on the right-hand side. The 2.14 has, on the left-hand side. The 2.14 has stayed where it is on the right-hand side. And what I needed to shift was that multiplier, the 1.2. I was timesing by that. So when I move it to the other side of the equation, it would become a divide, and I'd be dividing by that 1.2. Now, in a calculator, that's going to be nice and easy, and you're going to get your 1.78. But most people are fairly alarmed if I ask them to do that mentally. So I'm going to talk you through that mental process again. Now, there's 2 or 3 issues that go on here. So the first thing that goes on in the mind of most of my students is, oh my goodness, there's decimals, I can never possibly do this. Decimals are not that scary, so you've got to learn to deal with them. So when it comes to dividing, get rid of the decimal. 2 things. First of all, decimals on the numerator are not an issue, so you don't have to worry about those at all. So don't even concern yourself if they're on the top. If they're on the bottom, get rid of them. And that's nice and easy. If I want to turn a 1.2 into a number without a decimal, there's 1 decimal place, so I just have to times by 10. If there was 2 decimal places, so for example, if I wanted to get rid of the decimals on the numerator there, I'd times it by 100. And you can do anything you like to a fraction as long as you're consistent and you do the same to the top and the bottom. So if I want to get rid of that decimal on the bottom, I'm timesing it by 10, which means I need to times the top by 10 as well, so that I haven't actually changed the fraction. So if I times the top by 10, I'm going to get 21.4. Now, a lot of people are still going to be a bit nervous about that, because we haven't generally done a lot of division mentally since primary school. So what you've got to remember is that it's the bottom number into the top number. I'm going to highlight this as well. This is not a square root sign. The number of times I see my students say that it's 12 into, it's not a square root sign, so don't do that to me, please. 12 into the top number, which is now 21.4. Now, the next problem is that a lot of people just don't know their times tables. So I'm going to sort of talk you through the way I recommend my students do it. Keep a tally. It seems tedious, but if you have to do it, you have to do it. It's going to help you to get through that process. And once you've done your first number, if you're doing the division sort of through multiple numbers, you're going to reuse your list. So just get on and do it. So my first 12 would be 12. Sometimes I do a double list, so that's 112, okay? Then I'm going to basically add another 12 to that. So mentally what I'm doing here, add your ones first, okay, so that you don't go wrong. So 2 plus 2 is 4, and then I do my 10s, so the 1 plus 1 is going to give me the 2. And the first one was easy anyway. Then I'm going to add another 12. So again, mentally what I'm doing here is I'm dealing with my units first. So 4 plus 2 is going to give me a 6. 2 plus the 1 is going to give you a 3, okay? And away we go. Now, we already don't need to go any further here, of course, but that's the process we're going to wind up doing. So 12 into 21 would only go the one time. 12 into 2 went none, so I actually had a 0 there, but I don't need to record that. And I've effectively carried over that too. So 12 into the 21 went once. And I'm recording that so I keep my place values above that, the right-hand side of that 21. I need to keep my decimals in line. Now 112 was 12, so I would have had 9 left over there. So that 9 that I had left over, the leftovers always go to the top over there. And as long as you put your decimal in, you're all good. Now I've got to go 12 into that 94. And this is where we're going to have to carry on with our times tables list if you don't know your 12 times tables. And a lot of people don't, so that's okay, but, you know, get some strategies in place. So 6 plus 2 is going to give me my 8. 3 plus my 1 is going to give me my 4. Then I'm going to add another 12 because I haven't hit anything like 94 yet. So 8 plus the 2 is going to give me a 10. So I'm going to put my 0 down, carry the 1. 4 plus the 1 is 50, plus that 1 will give me 60. Then I'm going to add another 12. So that would be nice and easy. 0 and 2 is 2, 6 and 1 will give me the 7. I'm not even close to my 94 still, so I'm going to add another 12. The 2 and the 2 would give me a 4, and then the 7 and the 1 will give me an 8. Then I'm going to add another 12. The 4 and the 2 will give me a 6. The 8 and the 1 will give me a 9. So there's my 96. Now I can see I've gone too far, okay, because I was chasing 94. So I can see I'm going to have to stop at this one. And how many 12s have I got? 1, 2, 3, 4, 5, 6, 7 12s. So I'd record my 7. 7 12s were 84. I had 94, so I've got 10 left over. Leftovers always go to the top. So I'm going to put my 10 up there, and I'm going to put an extra 0 in. You can see I haven't changed that. It was 21.4, 21.40 is the same number. So you can add as many zeros as you need to, but your leftovers always need to go to the top. So now I'm going 12 into 100. 12 into 100, you can see here, I'm going to hit the 96 on my next one. And obviously I'm not going to be able to go further than that, or I'm going to exceed my 100. So I'm going to go 8 times. And that's going to be 8 times 12 is 96, so I'm going to have 4 left over. So my 4 left over would go to the top, and away I'd go. Now, my answer here was probably money, so 2 decimals is enough, but I need to do the third one just to check if I need to round that up or keep it the same. And so into 40 and say, because you've already done your list, it's now quite simple. You can see here that you're going to have to stop at the third one, so I don't have to, repeatedly do this once I've made a list. So that's going to go in 3 times, and I'm going to have 4 left over again, so you can see I'm actually going to get a recurring, but even if I didn't get a recurring, I could stop there. I just need this 1 extra decimal place to tell me if it was money in cents, so that I can round this to 2 decimals. So my final answer here would be the 1.78, which we already had above from a calculator. But if you do need to do it mentally, don't be alarmed, get rid of your decimals and carry on. And as I say, worst case scenario, you're going to have to do a list for your times tables if you're rubbish at them. There's plenty of you out there, don't panic, just get it done. Okay, now the next one's an example of multiplying. And multiplying with decimals is easier than the division for most of us, okay? And again, we're going to use this Arabic method. I have done a separate video on this method, so if you're not familiar with it, you might want to go back and have a bit more practice with it. I, for the moment, am going to assume that you're vaguely familiar with this, and I'm going to proceed. So, if I want to increase $218 by 14%, again, mentally I would have had to find 10% and then find 1% and then, times that by 4, and then I'm going to add it all on. By the time I do all that, the Arabic method would be quicker. So I would start by working out my multiplier. So 1 plus my percentage over 100, which will give me 1.14, and I'm going to times that by 218. It doesn't matter, the order in which you multiply numbers does not matter, so it doesn't matter if I'd put the 218 across the top and the 1.14 down the side, does not matter. And again, make sure your decimal places, you don't take any notice of those, you just put all your numbers in for the moment. And then we'll start multiplying. So the first one I'm doing is I'm multiplying this 2 by this 1, so 2 times 1 is 2. If it's a single digit number, it goes in the bottom corner. Then I'm multiplying the 2 by the 1. And again, 2 by 1 again is still a 2, so I'm going to put that there. 2 times 4 is 8, and again, single digit numbers in the bottom of the box. Next set, so now what we're multiplying is the next lot, so I'm now going 2 times the 1 to get this box, the first box here, 1 times the 1. So 1 1's 1, next box, 1 times 1 is 1, 1 times 4 is 4. Next one, 8 times 1, so 8 times 1 is 8, 8 times 1 is 8, 8 fours are 32. Now that was a double digit 1, so you can see I split that over the box like I did there. Then you're just adding up. So the adding up happens in the diagonal. So I'm adding up each of the diagonal sort of columns, if you like, there. So the first one will always be a number on its own. In this case, we've got a 2. The next one, 8 plus 3 is 11, plus another 4 is 15. So I'd record my 5 and I'd carry my 1 over. Now, when you carry it over, you can put it anywhere. So I'm just going to throw it there. But if my boxes were all full and I wind up carrying it on over here, don't forget that that is not ever going to be an 18. It would still be a 1 plus an 8. So just watch that, because if we're anywhere else in maths where we carry things over, it becomes like a 10s or whatever. In this case, it's not. It's just a 1. So put it wherever you like, but make sure you only count it as a 1 if it winds up sitting next to another number. So here I've got 8 plus 1 is 9, plus another 1 is 10, plus 8 is 18. So I'd write my 8 down, carry my 1 over. That gives me, in this next column, I'm adding up 1 plus 1 is 2, plus another 2 is 4. And then in my final column, I've got nothing to add, it's just the 2, so I put my 2. Final step is that I need to check how many decimal places do I have. Now in this question, there were 2 decimals. So if I'm looking here, I've got 1 decimal place here, 2 decimal places here. There was no decimals in the 218, but if there was, I would just add them on. It doesn't matter where the decimals occur. So here I've got 2 decimals, so I literally go 1, 2, put my decimal in, and my final answer would be that $248.52. And so that's that. Okay. Decreasing by a percentage is exactly the same sort of process, except now instead of going 1 plus, we go 1 subtract whatever our percentage was divided by 100. So it's just our percentage as a decimal. Times it by the original amount, and that will equal to the new amount, the decreased amount. And again, get used to all the words that might indicate that you're going to have a decrease. So we're going to have deflation, we're going to have, which is a price decrease on regular goods, depreciation, which is a price decrease on capital goods, discounts, losses, etc. So anything that implies that you've gone down should trigger your brain to use this formula. So my first example, decrease 210 by 3%. So I'd go 1 take my 3 on 100 times 210. So 3 on 100 is 0.03 when I move my decimal 2 spots. So 1 take 0.03. And again, some people don't like subtracting decimals in their heads, and the easiest way to do that is to imagine it being money. It's not, but most people can deal with money. If I said $1 take 3 cents, you'd happily tell me that it's 97 cents. Whereas sometimes when I say 1 take 0.03, people sit there and go, oh, hang on a moment, and mentally they struggle with it. So I can think of a 3% decrease as I'm decreasing something by 3%, or I'm keeping 97%. So when I go 0.97 times the amount, what I'm doing is finding 97% off, because that's the amount that I'm keeping. But the 0.97 is my multiplier. I times that out, and away I go. So if I was going to do this straight on my calculator, of course, that's going to be nice and easy. Times 210, and I would get an answer of 203.7, but I'm going to make sure we can do this mentally. So mentally, of course, we're going to make use of this 1% rule again, and then we're going to do it in 2 steps. So we'll find 3% and we'll subtract it and take it away. So 210, 1%, there's 100 lots of 1% in any number, so I'm dividing it by 100, which will give me 1% is equal to 2.1. I wanted 3%, so I'm going to times that by 3. So 3 lots of 0.1 would be 0.3. 3 lots of 2 would be 6. So I've got 6.3 is my 3%. And now if I want to reduce it by this, I'm basically going to go 210, take away 6.3. Now, again, if you haven't done any subtractions for a long time, keep all your units in line. And then we'll proceed. Now, I'm going to add, because people do tend to make mistakes with these, I'm going to add the 0.0 on the 10 to remind you that that 0 is in fact there. People tend to skip it and mess things up here and go 3 take 0 instead of 0 take 3. So 0 take 3, I can't do that. And so I have to start borrowing numbers. What you have to remember is that in this case I'd need to borrow from that next column, and there isn't any, so I need to borrow it from the next one along again. So I'm going to borrow my number from here. That's going to make that a 0, and when I borrow it, I have to put it in the next place. So, and then I can borrow from that. So then I'm going to borrow from that, so that will become a 9, and I'm going to carry that one over there. 10 take 3 is going to give me my 7. Keep your decimals in line. 9 take 6 is going to give me a 3. 0 take nothing will give me the 0, and then 2 take nothing will give me the 2. So if I had to do it mentally, it's not too much stress, but you need to remember to find the percentage, use that 1% or 10% rule, generally speaking, and then just make sure you remember to subtract it. Your second option here, though, would have been to do that Arabic thing again. So I will walk you through that, because depending on the numbers, sometimes the 10%, 1% thing takes you longer than it would just to do the Arabic. So my starting number was 210, and I'm timesing that by 0.97. So you put all your numbers down, and then literally just put boxes around them. So if I put my lines in, try and keep it roughly neat. Okay, so I've got my lines, and then again, put the lines. I'm going to keep these a little bit rougher just to speed it up. So put your lines around your boxes, and then what you're doing is halving each box. And as you halve them, it creates those sorts of columns. They're going to be a little bit rough if you've hand done it, but it's okay. Okay, so then I've got my boxes. I'm going to change colours just so that you don't accidentally add the purple numbers in. So the first one's all 0. 0 times 2 is 0. 0 times 1, 0 times 0. 2 times 9 is 18, so I put my 18 in there. Again, it's a double digit, so I split it over. 9 times 1 is 9. 9 times 0 is 0. 2 times 7 is 14. 1 times 7 is 7. 0 times 7 is 7. That's 0, sorry. I wrote it right, but I'm speaking it wrong. You're adding up in these diagonals. So my first diagonal, of course, is just that 0. My next diagonal is 7 plus 0 gives me 7. My next diagonal here is 4 plus 9, which will give me 13. So I record my 3, carry my 1. That is just a 1 plus 1. So I've got 2 plus 8 gives me 10, and I've got nothing else to add there. So I'd record my 0, carry my 1 over. 1 plus 1 is 2. Now I've got to check how many decimal places I've got. And I only had my decimals there, so I only had those 2 decimal places. There was no decimals in the top, so I just go 1, 2, and bang that in. Had I had more decimals, let's say I'd started with 2.1, then I'd just go, well, now I've got 4 decimals, so I'd go 1, 2, 3, 4, and I'd bang my decimal in there. So the decimals are not as scary as most people remember them being. So yes, hang in there, give it a go. So you've got a few options how you approach it mentally, and you choose, which way you prefer to do it. Okay, decrease 400 by 20%. So if you were doing your little equation, you're going to go 1 take your 20 on 100, which is 0.2. So 1 take 0.2, or $1 take 20 cents, if you prefer to think of it, would give me 80 cents. So I'm going to have 0.8 times by 400. Now, this is another good example of how to do your mental maths, because again, sometimes people will find their 10%, and this is not going to take you too long. So if I had 400, find 10%, 40. 20% 80. So I'm basically going 400, take away my 80. So, it's not difficult to do. But the other mental strategy you could use here to even bypass all that is to remember that when you're multiplying numbers like this, literally you can just go, well, essentially all I've got is 8 times 4. 8 times 4 is 32. But it wasn't 4, it was 400. So then I need to put my 2 zeros back on. And it wasn't 8, it was a 0.8. So you look at how many decimals did I have. Well, my final answer actually had 1 decimal. So my final answer here will have 1 decimal. And so it should be as simple as sort of doing that. So remember, multiply the actual numbers you've got together. And then deal with all your places. Sometimes people forget, though, they either don't add enough zeros or they don't put enough decimals in. So using something like that Arabic is bomb-proof. And if you know your maths is fairly weak, you might be safest to do that. But otherwise, keep an eye on that because it can save you a fair bit of time. Now, the chain rule is something you've hopefully done in Year 10, and this is basically where we just have multiple percentage changes. So this is something like inflation examples where the price might go up by a certain percentage for a certain number of years, and then it might go down the next year and up the next year, but we've got multiple changes going on. So that's why we call it the chain rule, because we're basically going to deal with each change one step at a time, and for every change you're just going to have another multiplier. If the change is repeated, so if I had an inflation rate for, let's say, 5 years, instead of doing that one multiplier and timesing it out 5 times, I can just raise it to a power of 5. Because it would be so let's say I had a 2% increase over 5 years, I'd have 1.02 for my first year, times 1.02 in my next year, times 1.02 in my next year, so on. And I'm going to do that 5 times, so it would be the same as saying 1.02 to the power of 5. So that's the kind of thing we're going to be doing here. So I've got an example here. Let's say I had a house valued at $420,000, and let's say it decreases in value by 2.5% in 1 year, then it decreases by 1% for the next 3 years, and then it increases by 2% the following year. What will it now be worth? And so basically, it doesn't matter which order I multiply things. So I've started with the price. So you do need the price first, because you're going to apply all these changes. So put your price down and then times it out by each of your multipliers. So your first one was a decrease of 2.5%. So I'm going 1, take my 2.5 on 100, okay? Or 0.97 is what that's going to wind up being. Or 975, my bad. And then I've got my next one, then it's going to decreases by 1% for the next 3 years. So 1 take 0.01 or 0.99 would be my multiplier. I would do that for the next 3 years. So, that's going on for 3 years. So instead of writing it like that, I'm just going to go the 0.99 to the power of 3, just to make it quicker for yourself. And then it goes up by 2%. So then I go there and I add the 2% for the next one, and I just apply it, so I can put that in my calculator just with those string of multipliers, and I'd get my final answer. Now, the common mistake here is that people want to just do it in one step and say, well, I've gone down by 2.5% 1 year, down by 1% for the next 3, so all up that's 3, 4, 5.5. People start going, and then I go up by 2. So all up I've gone down by 3.5. And so people want to treat it as one multiplier and just apply that 3.5 to the original amount. Now, the reason that's going to be wrong is that when I start this 1% in my second year, it's not 1% of the original amount, it's 1% of the already decreased amount. And same for the following year. Again, it's not that 1% of the original amount, it's 1% of an amount that's now already declined twice. And so you have to be super careful to make sure that you actually do use each of the multipliers in the correct order. Same with those initial questions. I will skip back up here because I forgot to mention that. So same when we did the questions where they give you the increase, like this one where they say if an item costs so much after a markup, and we had to go back and find the original price. It's the same deal. Sometimes people want to say, well, if it was a 20%, people want to say, well, if it was a 20% change, then I'll find 20% of this because that's easy. 10%, move the decimal one spot, double it, and I'll just take that off. That won't work because what you have found is 20% of the increased number, not 20% of the original number. And that's why we have to sort of think through that process as if we were doing it from scratch and then undo that process. So it is a very common trap, so just keep an eye on that. Okay, so inflation is just a percentage increase, or depreciation is a percentage decrease. These things actually apply to sort of general household items, general everyday sort of items. If it was a price increase on something like a car or a house, then we just use a different word, which is appreciation. And in fact, this depreciation applies to capital goods, and deflation would be the word that we'd use for everyday goods. But that's just being technical. They're all going to do the same, percentage increase or a percentage decrease. So in this question I've said, if a loaf of bread costs $4.80 now and inflation occurs at a rate of 2.4% for the next 4 years, what will the bread cost in 4 years' time? So I'd start with my starting price, so $4.80. I'm going to times it by my multiplier. In this case, I'm going up, so I'm having inflation, so I'm going up, so it'll be 1 plus. My inflation rate was 2.4%, so I divide that by 100 to make it a decimal. So really I've got 1.024. This is the bracket is your multiplier, so 1.024 is my multiplier. The 1 tells me I'm keeping the original amount, 0.024 increases it. And that was going to happen for 4 years. So instead of me repeating that multiplier 4 times, I just put this to a power of 4, and then I can get my answer. And, we're probably not going to be that mean to you mentally and make you repeat something. We're not really testing that you can multiply. We're actually really trying to test that you understand the concept of what you're doing. So once they get to this point where you're doing these repeated things, you're probably going to have a calculator. And don't forget, the only other thing you should remember, the answer when I put that into my calculator, I get 5.277655813. We're talking about money, so we need to use that logic of then rounding that to 2 decimal places because money is in dollars and cents. That sounds logical, but people always forget to do that. Sometimes if we end up with an answer of 5.2, say, then it's the same thing. I should put that 0 on because it is cents, and so you need to put your answers back into the context of the question. So in this case, I'd have $5.28. Goods and services tax is again just a percentage increase. The goods and services tax in Australia is 10%. So basically I'm always increasing everything by 10%. So if I was to use my little rule, I'd be going 1 plus my 10 on 100. 10 on 100 is 0.1. So I'll wind up with a multiplier of 1.1, which is what we've got in a little rule here. So to find the price of the good with GST, we'd get the original price. And we times it by the multiplier 1.1, which will give us the new price, the price with the GST. Sometimes they want us to do the reverse. They'll say, well, the price that I'm going to pay is this, and that includes GST, so how much was the original price? So it was like I was saying before, you can't then just find 10% of the price with the GST and take it off, because you'd be finding 10% of the bigger number, not 10% of the original number. So you'd think through that process and basically reverse it. If I was timesing by 1.1 to find the number, to undo it, I'm going to divide by the 1.1, which is what we're doing here. And effectively all I've done is rearrange that top equation. The original price has stayed where it is, the price with the GST has stayed where it is, and I've removed the 1.1 to get the original price on its own. I was timesing, so the opposite is dividing. So hopefully you can make sense of all that. Okay. The last thing you might be asked to do is to find the GST itself. So you've got two options. You could get the original price with GST, take away the original price. That's certainly going to work. But often it's quicker just to get the price with the GST, if that's what they've given you, and divide it by 11, because the final price is going to have 11 lots of 10%. There's 10 lots of 10% in 100% or a full price, and then we've added 10% to that. So all up we've got 11 lots of 10%. So that's why dividing by 11 will give us back the GST amount. If they didn't give you the price with GST in the original question, then you'd obviously just get the original price and times it by 0.1 to find 10% to get your GST. Okay, profit and loss. I might just do this in another video because I feel like this one's getting